So here's a quick challenge. Given this array, you need to find the next greater element for each element. So you can pause the video, take 30 seconds and try to come up with an answer. So I think you got it. Now here's the thing. The exact problem appears in Amazon interviews and majority of the people got stuck in a brute force trap. So today I will be showing you that how to come up with the optimized version of this. So here's the big example in which for those who didn't understand the question, see, if I'm standing over here, I need to find the next greater element which is present on the right hand side. So for element 2, the next greater element is 4. For this element, the next greater element is 6. For 1, it is 6 and so on. Okay, so here you can see that if you're standing over here, the next greater element for this is 4. For this is 6. For this is also 6. For this, it is 7. Okay, not 3, 7. For this is also 7. For this, for element 7, the next greater element is 9. For this, it is 9. For this, it is 10, 10. And see guys, for this, there is no building present on the right hand side. So it is -1. Okay, so for any particular element, if you see that on the right, there is no element greater than the current element, then you need to put -1. Okay, so basically you need to return this element. Okay, so obviously these are 10 elements. Okay, so you have to have the array. Okay, now let's see the approach one. Okay, so the brute force approach. So over here, what you can do, let me take the current array. Now standing over here, what you can do, you can have a for loop in which you will be iterating on the right hand side. And if you found the first element which is greater than the current element, you will just put in the resultant array and then you will break from the current for loop. Okay, so if I'm standing over here, the next greater is 4. Then for this is 6, 6 and so on. So first create the resultant array in which the size will be n. Okay, then we will be having a for loop in which I will be running from 0, I is less than n, I plus plus, and we will be having a for loop in which j will be running from I plus 1, j is less than n, j plus plus. After this, you will check if array of I is lesser than array of j. That means you found the element which is greater than the current element. So first you will store that element in the resultant of I, and then you will simply break from that current loop. That means the inner loop. Okay, but it might happen that for the current element there is no greater element present on its right. Okay, so initially what you will do, you will store -1 in rest of I. Okay, so if you're not able to enter inside this loop, initially -1 is already present. Okay, okay, for this was it for the brute force. Okay, now talking about the performance of this code. So basically, since we are having two for loops, so it will be order of n square. And about the space complexity, it will be constant. Someone might argue that we are creating an array of size n. Okay, so it will be order of n. So, but the thing is that, okay, they want the answer in a form of an array only. Okay, so we are not taking the space for our purpose. Okay, so hence the space complexity is constant. Now over here, I do see that this time complexity is order of n square. So we need to optimize this. Okay, so approach 2. Now here I'll take two examples, okay, to show you that what we are doing over here. Now over here, this is an example. Okay, I will be taking of help of some data structure. Okay, so if you know that what is this data structure, you can comment it down. Now we will be starting from the end and moving towards the left hand side. Why? Since we are moving towards the left, so for the element present on the left, we know that what is the future buildings which are taller than current building. Okay, so that's the reason I'm moving from right to left. Now since we are starting from over here, so for this building there is no element present on the right hand side, so I'll simply mark -1. Okay, and since we have encountered this building, okay, so I will be storing the height of this building in this data structure. Okay, and I'll move further. Now for element 8, over here I do see that the next tallest building is present inside this data structure because we are moving from right to left. Okay, so I'll have 10 over here. Okay, but see guys, for this building, the next tallest building present on the right is 8, not 10. So I need to keep, or I need to store 8 in this data structure as well. Okay, and for this 7, the next tallest building on the right is 8. Okay, so since we have used the recent element, okay, so obviously this data structure is nothing but stack. Okay, now based on this, okay, so whatever building you have encountered, you need to store that building inside the stack. Okay, that's the rule number 1. Now let's have different example. Okay, imagine that we have encountered these 2 building and we have stored inside the stack. When we are standing at this, okay, the element present on the left, okay, or the building present on the left, can 8 be the answer for them? The answer will be no. Why? Because for this for this element, 9 is the tallest, right? 9 is the tallest, so 8 can never be the answer. So whenever I encounter any building in which it is taller than the top of the stack, I basically need to pop that elements. Okay, again I'm saying elements, not element. Okay, so I need to keep popping unless and until I don't see any element which is greater than 9. Okay, so I will be keep popping. Over here I do see that only 8 is present, so I'll just delete one element. Okay, and for 9, the next greater element is obviously 10. Okay, because I have popped out 8, and obviously 8 is not the answer for this, right? So 10 is the answer, and for this it was 10, and for this it was 9. And don't forget to push each and every element inside the stack, so 9 is pushed now. Now for element 5, the greatest element on in the stack is 9. Okay, and I'll push 5 to it. Now for element 7 also, here you can see that, imagine that building present on the left hand side, 5 can never be the answer, right? Because 7 is the tallest one. Okay, so I'll pop this 5. Okay, and I'll keep popping unless and until I don't see any element which is greater than 7. So over here 9 is the greatest, so I'll stop it now, and I'll store 9 over here. Okay, which is nothing but the top of the stack. And don't forget to have 7 over here as well. Okay, so in this way basically we will be solving this problem. So let's now come to the original question. Now initially the stack is empty. Okay, so obviously for this the element will be -1, and don't forget to push 10 to it. Now for 8 over here, the top of the stack is 10, so I'll store 10 and push 8 into it. Now for element 9, I do see that the top of the stack is 8, which is lesser than 9. So I'll pop this 8. Okay, and I'll have 10 over here and 9 over here. Okay, this is stack. Now for 5, the top of the stack is 9 and push 5 to it. Now for 7, see the elements present on the left hand side. Okay, 5 can never be the answer, right? So I'll pop 5 first. Okay, and I'll keep popping unless and until I don't see any element which is greater than 7. So I'll stop it till 9, and 9 will be, I will be storing 9 over here and 7 over here. Okay, and for 3, 7 will be the answer and store 3 over here. And for 6, 3 can never be the answer, right? So I'll pop this 3 and 7 over here and 6 over here. Now for 1, 6 is the answer and store 1 over here. Now for 4, 1 can never be the answer, right? So I'll pop 1 and store 6 over here and 1 over here. Sorry, 4 over here. And for 2, I'll have 4 over here and 2 over here. And that's it. We are done. So we found the answer. So obviously we need to return this, right? So we will be creating an array. But this question was asked in LeetCode and it was similar one, okay? So hence instead of using the array, okay, the resultant array, I will be using the hash map. Why? I'll tell you in a bit. Okay, so I will be needing two data structures. First one is stack and the second one is hash map. Okay, so let me create the stack and hash map first in Java. Okay, so this is based on Java. So for Python, C++ and JavaScript, you can just basically Google it. Now next what you need to do, I need to have a for loop in which I will be coming from n minus 1. I should be greater than 0, greater than equals to 0, and I minus minus since we are moving towards left. Now see, when I was standing over here, 8 was stored inside the stack. Okay, so I need to check whether inside the stack, basically at the top of the stack, whether any element is present which is smaller than the current element or not. If it is, then I need to pop it. Okay, and I need to keep popping. So I need to have a while loop in which I will be comparing the top of the stack with the current element array of I. Okay, so over here, if I found out that the current element is greater than the top of the stack, I need to keep popping. But see guys, over here I am checking the stack, the top of the stack, but it might happen that the stack might be empty. Okay, so I need to have that condition as well. So stack dot size should be greater than 0. If it is, then only I will move forward. Okay, now if this condition is true, I need to pop stack dot pop. Now see, after popping 8, I need to store 10, right? Now where I will be storing, see, for this 9, okay, the answer is 10. So I will be storing inside the hash map in a form of a pair. For 9, the next greater element is 10 like this. Okay, so hash map dot put current array, sorry, current element, comma, top of the stack, that is peak. Okay, but see, again we are storing top of the stack, but it might happen that the stack might empty, so I need to have conditions. So first I'll check if stack size if it is 0, okay, then I need to store -1 to it. So hash map dot put current element, comma, -1, because the stack is empty. Else if the stack is not empty, then I need to have this function, right? And after storing, don't forget to store each and every element inside the stack. So stack dot push current element, and that's it, we are done. So here you can see that this has happened with just one for loop. Okay, so talking about the performance of this code, the time complexity for this is order of n, and the space complexity is order of n. Why order of n? Because we have used stack over here. Okay, hence order of n. Now why did I took hash map, okay, instead of array? See, because in the LeetCode they are asking in this way. So this was the original question, and they also giving one more array. Let's have AR. Now this array is nothing but the subset of the array which is present on the right hand side. So 2, 4, 6, 5, 9. after finding out the greatest element for each and every number, okay, you need to come over here, and for 2 you need to search what is the next greater element for 2. So answer is 4. So you need to have 4. You need to have 4. For this element, you need to search for the answer. So this will be 6. For this 6, you need to search. The answer is 7. So you need to write 7. For this 5, the answer is 9. So you need to write 9. For this 9, you need to search in this array and you need to have 10 over here. So like this, you need to return the answer. And if you go with this now, then the time complexity will be n square. N square in a sense, if this is n and this is m, so it will be m into n. Okay, but in the question it is asking us that it has to be solved using m plus n time complexity. Hence I have used an hash map. So if you store this answer inside the hash map, then you don't need to search for each and every element in the hash map. The searching can be happen in just order of one time. Okay, hence I have used hash map. So I believe you got this. If you didn't, you need to dry run it by yourself. Okay, so that's it from my side. I'll see you in the next lecture. Till then, keep practicing. Thank you.